if any of you watching, but with my two students there, we grabbed one of these little guys, these spectrometers, okay? And what we did is we just put our little eyes right through them, and we saw a bunch of different colors. Now, where did all the different colors come from? Remember, light is different colors because it has different energies. So remember that red light, right, is going to have so much energy, and then you get something a lot more ambient, a more mellow color, like blue, right? That's not going to have the same amount of energy or the same wavelength. Now, if some physicists are watching me and they're saying it doesn't have to do with that, it has to do with wavelengths, but energy and wavelengths are interchangeable, okay? So we're just going to say that it has different energies. Now, this ball, this little ball right there, tells us where an electron might be, maybe. By the way, it reminds me of a joke I heard about Schrodinger and Heisenberg, but I'll tell that later. Anyway, inside of this, these orbitals, sublevels, imagine that there's a mall, right? And so the mall is the sublevel. Inside of the mall are stores, and inside of these stores are electrons. Now these sublevels are going to kind of categorize where the electrons are, and in what energy levels. Not specifically, but rather the general area based on how much energy they have. Remember that not all electrons have the same amount of energy. Some have a lot more energy than others. You have the valence electrons all the way on the outside, and the ones closest to the nucleus. So we divide these sublevels into three main categories: S, P, D, and F. Now the S sublevel can hold 2 electrons. It is the smallest of the sublevels. And the F orbital can hold 14. It is the largest of the sublevels. And we'll go ahead and talk about that in just a second.